All right, welcome to Chapter 2, the distance between 2 points. Today we're going to learn about the distance formula, which is to find that distance. Now if we put the points 1, 1, and 4, 5 on a piece of paper, and we connect them with a line. Now, it's very difficult to just um, find this exact value. But we can easily see that horizontally, we move to the right 3 units, and vertically, we move up 1, 2, 3, 4 units. So it's easy to find horizontal and vertical distance to a new location, but to find from here to here, it's not as easy to just look at it and see. So now what we can do is we can use Pythagorean's theorem because we know this is a 90-degree angle. So 3 squared plus 4 squared is equal to c squared, or 9 plus 16 is equal to c squared, which is 25. Now when you square root both sides, in algebra you learned that what you should do when you square root is to take the positive and negative of that answer. However, does it make sense to say that a distance is -5? Not in this case. So we're going to be content with just saying c is equal to 5. Now, using the same method, let's find the distance between -2, 1 and 4, -3. So -2, 1, 4, -3. Now I'll draw this line. Now what I want you to do is pause the video and see if you can figure out this distance on your own. All right, hopefully you're done. What we'll do is we'll look at the horizontal and the vertical. Horizontally, I move to the right 1, 2, 3, 4, 5, 6. And then I move down 1, 2, 3, 4. So if I want to find this length between my 2 points, I'll take 4 squared plus 6 squared is equal to c squared, which is 16 plus 36, which is 52. So now I'll take the square root of 52. Now to take the square root of 52, what I'll do is take out this calculator, and this is just the calculator that the computer comes along with, so 52 square root. And it looks like 7.21 is an approximation for this value. Now, this is what we'd call the exact value. It's exactly the square root of 52, and this would be a decimal approximation. All right, now we've done 2 examples. Let's see if we can find any shortcuts. Now let's look back here. This, I went from 1 to 4. See how my x went from 1 to 4? And then the distance I got was 3. Over here I went from 1 to 5, and the distance I got was 4. So what we're going to do is we're going to subtract, hopefully you saw that. If we subtract 4 and 1, we get 3. So I'm going to subtract my x values and subtract my y values. So if I have x2 minus x1 and y2 minus y1, those are the values that I put into Pythagorean's theorem. So I'm going to take whatever I get from this and square it, add it to whatever I get from this and square it, and that's going to be my distance squared. Now I need to square root both sides, so if I take the square root of all of this, then I have this formula. Now this formula they just call the distance formula. Now, some people love using formulas, and you can go right ahead and try to memorize this and use it all the time. Some people just like to think about it conceptually, like this, like our previous problems. Whatever works the best for you, go right ahead and use it. Now, find the distance between the points 1, 5 and negative 2, 9. Well, I'm going to do two different ways. One, I'm going to use our formula. If I use my formula, my distance is going to be negative 2 minus 1, which is going to be negative 3. So I'm going to take negative 3 squared plus y2 minus y1, which is going to be 4 squared. And that's going to be 3 squared, which is 9, plus 4 squared, which is 16. So d is going to be the square root of 25, which is 5. Now another way you can do this, by drawing a triangle, is think about what's the distance horizontally. Between negative 2 and 1, how far over do you go? The answer is 3. Now think about vertically. Between 5 and 9, how far do you go? That's 4. So if you have a 3, 4, then you can just use Pythagorean theorem. 3 squared plus 4 squared is equal to c squared. And then we can get the same answer. So we get 5 in either case. One is using algebra and a formula. The other one is drawing a picture and going from there. All right, find the distance between 19 and 23. Pause the video and see if you can do this one on your own. All right, we would take the d equals x2 minus x1, which is going to be 4 squared. Negative 27 minus negative 23. Ooh, I need a plus there. Is going to be negative 4 squared. Now I got 25 minus 16 to be 4. Hopefully you're screaming at the screen and saying that that's 6. All right, wonderful. So d is equal to the square root of 36 plus 16, which is again the square root of 52, which we found out up here is 7.21. Now, don't think that all values are either 5 or square root of 52. That just is how this one has turned out. All right, now you guys find the distance between 4, 3 and 10, 8. All right, now I'm going to, last time I used the distance formula, now I'm going to do the triangle method. Between 4 and 10, that goes up 6. And between 3 and 8, that goes up 5. So to find the distance over there, we just take 5 squared plus 6 squared is equal to c squared, or 25 plus 36 is 61. So I just have to find the square root of 61. So if I clear this out, 61 square root, that's 7.81. So 7.81 is now my distance between those points. Now there's some terms that we're going to need for this homework, and you probably have seen these throughout middle school, but we're just going to mention them again. A triangle that is equilateral has all sides equal. An isosceles triangle will have at least 2 sides that are congruent. Now, I should have actually used the word congruent up here, because the side lengths could be equal, but the sides would be congruent. Congruent means if a shape has the same measure as another shape. Scalene, all sides have different lengths. Now a right triangle has a right angle. An acute triangle, all angles are less than 90 degrees. Obtuse triangle, one angle will be greater than, or is greater than 90 degrees. Now remember, it only needs one angle to, in an obtuse triangle to be one angle to be over 90 degrees to be obtuse. Now quadrilaterals. Now hopefully you've seen all of these terms before: kite, trapezoid, parallelogram, rhombus, rectangle, and square. But I'm just going to help you remember. A kite is an object that looks like this, where it has two sets of congruent sides that are connected. So, however, these two and these two cannot be the same sides. A trapezoid is a quadrilateral, and remember, quadrilateral is an object that has four sides. A trapezoid is something that looks like this, and it's a quadrilateral with only one set of parallel lines. Parallel lines. Whereas a parallelogram is something where there are two sets of parallel lines. Having trouble with the word parallel here today. All right, rhombus. A rhombus is a type of a parallelogram. So it's a parallelogram where all the sides are equal. So it's a parallelogram with equal sides. Now, another way we could say this is we could say it's an equilateral parallelogram. And a rectangle is a quadrilateral with each angle being equal. So we could call this an equiangular parallelogram. And a square is a combination of a rhombus and a rectangle. It's a parallelogram that's equiangular and equilateral. All right. Hopefully you've seen those terms before, and that will get you through the homework. Good luck.